In this segment, we're going to talk about ionic compounds, and more specifically, naming ionic compounds. So, quick review, ionic compounds are made of ions, and ions are basically charged particles. You can think of them as charged atoms, if that helps you. They are atoms that have gained or lost an electron or electrons. Ionic compounds are also made of a metal and a nonmetal. If they're binary. If they're not binary, it's a metal and a polyatomic ion. A polyatomic ion, if we break the word apart, poly means many. An atom or atomic, many atom. And then ion is, well, ion. So many atom ion, it's actually an ion that is covalently bonded. So not ionically bonded, but covalently bonded, that has a charge. And we'll talk about covalent bonds in our next segment. When you write ionic compounds, you always write the positive ion or cation first. So that's the metal in our last example. So positive ion is called a cation. That's the metal, so you write that first. And then you write the nonmetal or the anion second. Negative ion. So when we have a few ionic compounds, for example, sodium chloride, sodium is a metal, chloride is a nonmetal, so we wrote the positive ion first and the negative ion second. So sodium, when it becomes an ion, forms a positive 1 ion. Chloride, when it becomes an ion, forms a negative 1 ion. And that's in another segment describing that. Right now we just want to be able to write them and name them. Okay, so writing ionic compounds. So we're going to remember to write the metal first, the nonmetal second, and a couple of rules you need to know. So metal first, nonmetal second. Metal or positive ion first, and nonmetal or negative ion second. So the sum of the charges of these two should equal 0, or you could also say the sum of the charges of the positive ions should equal the sum of the charges of the negative ions. It's really not as complex as that one sounds. And then the formula you write is the smallest whole number ratio of ions. So in our sodium chloride, you would not write Na2Cl2. So don't do that. So let's take some examples, assuming you already know how to find the charges of ions. We're just going to create some ionic compounds. So let's say we're going to do potassium and chloride. Potassium has a +1 charge, chloride has a -1 charge. We want their sums to be equal. Is that true? Yes, we have a +1 and a -1. So when that forms a compound, it will just form KCl. What happens if we have unequal charges? What if we have, for example, potassium and oxygen? So we know from prior experience that potassium is +1, oxygen has a -2 charge. Now what happens? So we want to even this out. We want to make sure the sums are equal. So we're going to want 2 potassium ions to balance out our -2 charge on our oxygen. So we end up with K2O. And let's do one more as an example. Aluminum we know is a +3 ion. Oxygen, -2 ion. This takes a little more work, and we could use algebra to do this and figure out how many of each we would need for the sums to be equal, or for the overall charge of the compound to be 0 is what our goal is, but there's a really easy way to do that. If you get rid of the charges and crisscross just the numbers down to subscripts, so on the aluminum, we're going to crisscross this -2 and get rid of the charge and just put a 2 down there. And then we're going to do the same thing for the oxygen. We're going to take the 3 and we'll put it down there. And if you check that algebraically, you realize if I have 2 +3 charges and 3 -2 charges, the sum of their charges is equal, and also the sum of the charges equal 0. Now, naming. If it's a binary compound, which means it's made of only 2 different ions. So all of the examples we've done so far have been binary compounds, binary ionic compounds, so 2 different ions. When you name that, you take the name of the cation, or the positive ion, and you write that first, and then you're going to write the base name of the anion, that's an N, base name of the anion with the ending IDE. For example, our NaCl, the name of the cation, the name of Na, is sodium. The name of Cl is chlorine, but as an ion, we're going to take the base name and we're going to change the ending to IDE. So instead of chlorine, it's going to be chloride. Same thing would happen with our potassium chloride. And then our Na2O, again, name of the cation, sodium. And for oxygen, the base of oxygen is really just ox, and then we're going to add IDE to it. So sodium oxide. And then the last one we did, Al2O3, name of the cation, aluminum, and then our oxygen again is oxide. Some metals form cations that have different charges. These are generally the transition metals. They're on your polyatomic ion list. Some of them are listed there for you to look at. In that case, we have to distinguish which cation we're dealing with when we name it. So one that forms two different ions is iron. We could have iron 2+ ion, or we could have iron 3+ ion. So we need to distinguish when we form a compound which one it is. The stock name is iron 2, and we're going to use parentheses with Roman numerals. So that's iron 2, and for Fe3+, to designate the charge of it, we're going to call that iron 3. So the Roman numeral in parentheses tells us which cation and what the charge is on the cation. So if we were to name FeO and Fe2O3, well, we know the charge on oxygen is -2. So for the first compound, if oxygen is -2 and we only have one iron ion there, then that iron has got to be iron +2. So we would call this iron 2 oxide. The second compound, again, we know that oxygen is a -2 charge. If we have 3 of them, to balance this out, to make sure the sums are equal, then our iron must be an iron 3 ion. It's important that the Roman numerals are uppercase and not lowercase. So we're not going to do iron 3 like that. And it's important that they are enclosed in parentheses. Now we're going to name compounds with polyatomic ions. Remember, polyatomic ions are covalently bonded and therefore have to stay together. So that's going to be the biggest thing, is that we make sure those polyatomic ions stay together. Other than that, it's the same idea for making them. It's the same idea for naming them. You're going to name them and use the chart as reference to name these. So you need to know the name of the polyatomic ions. So let's do some examples. There's our friend sodium. We know from experience that the charge is +1, and it's going to combine with NO3. So the first part, we're going to call sodium sodium, and we're going to call NO3 what it's called on the chart, which is nitrate. Let's get a U in there somehow. U, sodium. So sodium nitrate. I think the hardest part about polyatomic ions or compounds with polyatomic ions is actually forming them or creating them. So what if we went backwards and I told you had calcium hydroxide? How would you write that out as an ionic compound? Put an E on the end. So from experience, we know that calcium is +2, and if we look on our chart, hydroxide is a negative charge. So what happens? How many hydroxides do we need to even out the charges, or the sum, for the calcium ion? Okay, so we're going to need 2 hydroxides to do that, to balance out those charges. So what you're going to do is enclose that polyatomic ion in parentheses. Remember, they have to stay together, they function as one. And we put a 2 on the outside of the parentheses, telling me that I have 2 hydroxides. That's what this says. This says I have 2 hydroxides, or 2 hydroxide ions. Now what I've seen before is this. This is completely different. This tells me I have 2 hydrogens. So 2 hydrogen ions, not the same thing. So make sure you have these parentheses enclosing that hydroxide so we know that you have 2 hydroxides and not just 2 hydrogens.